My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Machine Learning as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: write a short note on K-medoids clustering. K-medoids clustering. K-medoids clustering is a machine learning method used to group similar data points into K clusters. It is similar to K-means, but instead of using the mean of points as the cluster center, it chooses an actual data point, medoid, as the center of each cluster. A medoid is the most centrally located point in a cluster, which makes this method less sensitive to outliers. How it works: 1. Choose K random data points as medoids. 2. Assign other points to the nearest medoid. 3. Swap medoids with other points to reduce the total distance within clusters. 4. Repeat until clusters are stable. Example: imagine grouping cities by temperature. A medoid is an actual city, not an average value, representing each group. Key points: better for noisy data than K-means. Slower for large datasets but more accurate in many cases. Memory tip: K-medoids is equal to medoid is equal to real point. Next important short question is: 2. What is spectral clustering? Spectral clustering. Spectral clustering is a machine learning method used to group data points, especially when the clusters are not simple shapes like circles. Instead of working directly with distances, it uses graph theory and the eigenvalues of a similarity matrix to find clusters. How it works: 1. Create a similarity matrix showing how close points are to each other. 2. Build a graph where nodes are data points and edges show similarities. 3. Use eigenvalues and eigenvectors of this graph to reduce complexity. 4. Apply a simple algorithm like K-means on this new representation to form clusters. Example: if you have photos of fruits, apples, bananas, grapes, that aren't easily separated by just size or color, spectral clustering finds hidden relationships and groups them better. Key points: best for complex-shaped clusters. Works well with graph data or nonlinear relationships. Spectral means using eigenvalues, spectrum, to understand data. Tip to remember: think spectral is equal to graph plus math magic for clusters. Next, Unit 4. Top 5 long questions. First important long question is: explain the concept of hypothesis testing with an example. Hypothesis testing. Hypothesis testing is a statistical method used to make decisions or draw conclusions about a population based on sample data. It helps us test an assumption, called a hypothesis, to see if it is likely to be true. Key terms: 1. Null hypothesis, H. The assumption that nothing has changed or there is no effect. 2. Alternative hypothesis, H. The opposite claim, which says there is an effect or difference. 3. P-value, the probability of getting the observed results if H were true. 4. Significance level, alpha the cutoff, often 0.05, to decide if we reject H. Steps: 1. State H and H. 2. Collect data and calculate a test statistic, like t-test or z-test. 3. Compare the p-value with alpha. If p less than or equal to alpha, reject H. If p alpha, fail to reject H. Example: a teacher claims her student's average exam score is 70. H. Mean score is equal to 70. H. Mean score is not equal to 70. She takes a sample of 30 students and finds the average is 75. After calculating, the p-value is equal to 0.02. Since 0.0 to 0.05, she rejects H and concludes students perform better than 70 on average. Importance in machine learning. Hypothesis testing validates if a model improvement is statistically significant or just due to chance. Used in A/B testing for websites, product changes, or algorithms. Easy tip. Think of it like a court trial. H is not guilty default assumption. Evidence, data, must be strong enough to reject H and prove guilt effect. Next important long question is to discuss ensemble methods in detail and compare bagging, ADA boost, and gradient boosting. Ensemble methods in machine learning. Ensemble methods are techniques that combine predictions from multiple models, called weak learners, to create a stronger and more accurate model. Instead of depending on one algorithm, ensembles use the wisdom of crowds to reduce errors. They improve accuracy, reduce overfitting, and handle complex datasets well. Types of ensemble methods. 1. Bagging, bootstrap aggregating. Trains multiple models on random subsets of the training data with replacement. Predictions are averaged, regression, or voted classification. Example, random forest is a famous bagging method. Use works well to reduce variance and overfitting. 2. ADA boost, adaptive boosting. Trains models sequentially. Misclassified samples get higher weights so the next model focuses on them. Final prediction is a weighted sum of all models. Use good for improving weak learners but sensitive to noisy data. 3. Gradient boosting. Builds models sequentially like ADA boost but minimizes loss function using gradient descent. More powerful and flexible than ADA boost. Example, XGBoost, Light GBM. Use high accuracy for structured tabular datasets. Comparison table. Feature bagging, ADA boost, gradient boosting. Training style parallel sequential. Focus reduce variance reduce bias and variance. Weight adjustment no yes via gradients. Example, algorithm random forest ADA boost classifier XGBoost, Light GBM. Example. Imagine predicting student grades. Bagging, many models predict grades from different random samples, and their votes are averaged. ADA boost, next model focuses more on students who were mispredicted earlier. Gradient boosting optimizes predictions step by step to reduce total error. Easy tip. Bagging is equal to same level teamwork. ADA boost is equal to focus on mistakes. Gradient boosting is equal to step-by-step improvement with math power. Next important long question is 3. Explain K-means clustering algorithm with steps and example. K-means clustering algorithm. K-means clustering is an unsupervised learning algorithm used to group data points into K clusters based on similarity. It tries to place similar items in the same group so that objects in one cluster are closer to each other than to objects in other clusters. Think of it as dividing students in a class into groups based on height and weight. Steps of K-means. 1. Choose K. Decide the number of clusters, K, you want. 2. Initialize centroids. Randomly select K data points as initial cluster centers, called centroids. 3. Assign points to clusters. Each data point is assigned to the nearest centroid, using distance, usually Euclidean distance. 4. Update centroids. Calculate the mean position of all points in each cluster and move the centroid to that position. 5. Repeat. Keep reassigning points and updating centroids until they stop changing or move very little. Example. Imagine you have the heights and weights of 10 students. You want to divide them into two groups, K is equal to 2. 1. Randomly pick two students' measurements as centroids. 2. Assign each student to the nearest centroid. 3. Recalculate centroids as the mean height and weight of each group. 4. Repeat steps 2 to 3 until groups stabilize. Finally, you'll have to clear clusters, one for lighter students and one for heavier students. Advantages. Easy to understand and fast. Works well with large datasets. Limitations. Must choose K beforehand. Struggles with irregular shaped clusters or outliers. Easy tip to remember. K-means is equal to K groups plus means, average. Make groups based on average positions. Next important long question is 4. Compare hierarchical and density-based clustering methods. Hierarchical versus density-based clustering. Clustering is a way to group similar data points together. Hierarchical clustering and density-based clustering, DBSCAN, are two popular methods. Let's compare them. Hierarchical clustering builds a tree-like structure, dendrogram, of clusters. Two types. 1. Agglomerative, bottom-up start with each point as its own cluster and keep merging closest clusters. 2. Divisive, top-down start with one big cluster and keep splitting. No need to predefine the number of clusters. Good for visualizing relationships between data points. Works well when clusters are well separated. Example, grouping students by marks, start by grouping similar marks, then combine groups step by step. Density-based clustering, DBSCAN. Groups points based on density of data points in an area. Points in dense regions form clusters. Points in sparse areas become noise outliers. No need to set the number of clusters beforehand. Works well for arbitrary shapes and noisy data. Needs to parameters. EPA's neighborhood radius. MinPTS, minimum points in a dense area. Example, in a mall, crowded areas, more people close together, form clusters, while isolated people are outliers. Comparison table. Feature hierarchical clustering density-based clustering, DBSCAN. Cluster shape best for spherical clusters works for any shape. Need for K, hash clusters, no, but must cut dendrogram no. Handles noise outliers poorly well. Visualization easy with dendrogram not as simple. Speed slower on large datasets, faster for large datasets. Easy way to remember. Hierarchical, like making a family tree of data points. DBSCAN finds dense crowds of points and calls them clusters. Next important long question is 5. Discuss the role of clustering in machine learning. Explain different clustering techniques with diagrams. Role of clustering in machine learning. Clustering is an unsupervised learning method used to group similar data points into clusters without predefined labels. It helps machines find patterns, organize data, and understand hidden structures. Role in machine learning. Helps in exploratory data analysis, finding trends. Used for customer segmentation, image compression, anomaly detection, and recommender systems. Makes big datasets easier to analyze and visualize. Clusters can serve as features for supervised models. Popular clustering techniques. 1. K-means clustering. Divides data into K clusters based on distance to the cluster center, centroid. Simple and fast, best for spherical clusters. Example, grouping customers by monthly spending. Diagram. O, cluster 1, cluster 2. O, 2. Hierarchical clustering. Creates a tree, dendrogram, of clusters by merging or splitting. No need to fix the number of clusters initially. Example, grouping students based on scores gradually. Diagram. Root C1 C2 ABCD 3 DBSCAN density-based clustering. Finds dense regions as clusters and marks sparse points as outliers. Works well for irregularly shaped clusters. Example, detecting crowded zones in a shopping mall. Diagram. Noise points separate. 4 K-medoids clustering. Similar to K-means but chooses actual data points as centers, medoids. More robust to outliers. Quick tip to remember. K-means fast and simple. Hierarchical makes a tree. DBSCAN finds natural shapes and detects noise. K-medoids like K-means but safer with outliers.